Okay, we're still in section 3.3, and the other thing I'm going to do in section 3.3, and this was the last objective, is to convert between the different forms of the quadratic equation when possible. So in this case, I'm giving you a quadratic in polynomial form, and I would like you to write it in x-intercept form. So if you recall, the x-intercept form is going to be the a times x minus s times x minus t form. Okay, so that's the form we're going for. So if this is the case, anytime you have this leading coefficient out here, we need to go ahead and factor that out. So let's change this to g of x is equal to 2, parenthesis, we're going to take out the 2, so that's going to give me minus 2.9 x minus 13.5. Now let's go, keep in mind your x-intercept form. What do you need to know? Well, we need to know the x-intercepts. So from this form we have it in now, the polynomial form, how would we find those x-intercepts? And the answer is we'd find them by using the quadratic formula. So we're going to have x is equal to negative 2.9 plus or minus the square root of the 2.9 squared minus 4 times a times c, and all of this over 2 times a. And we're going to simplify this, and when we simplify this, we get negative 2.9 plus or minus 7.9, all of that over 2. And then we do the 2.9 plus 7.9, and we get 2.5. That's 1. And then we get minus, and we get the 5.4. So those are my two x-intercepts. So now that I know my two x-intercepts, then I can go back and I can go ahead and write this equation. And that equation is going to be f of x is equal to, keep in mind I factored out that 2, so I'm going to keep that 2, that's my a, so x minus 2.5 and x plus 5.4. And that's going to be my x-intercept form for this quadratic equation. All right, now we're going to go from polynomial form to transformation form. So transformation form is going to be the one that involves the h and the k, so you're using your vertex. So transformation form is your f of x is going to be equal to a x minus h quantity squared plus k. So in this case, what we need to find is our vertex, or really what you're going to do in this case is you're going to complete the square. All right, so if we're going to complete the square, keep in mind we did this in the last section. You notice that you have your negative 5 there. So I'm going to get rid of the f of x for right now, and I'm going to say that negative 5x squared plus 6x. I'm going to leave myself a blank, and I'm moving the 1 to the other side, so that becomes a positive 1 when I move it over there. And then I'm going to give myself a blank here. Now I have to deal with that 5. I have to move that negative 5 out. So I'm taking out the negative 5, and I get x squared minus 6x. I'm going to leave myself a blank again, and then now that's going to become a negative 1/5. And because I factored out the negative 5, so it changes my sign. Now from here, to complete the square, you take half of this number, which is negative 3, and then you take that and you square it, which is going to give me 9, and that 9 is going to go here, and that 9 is going to go here. Okay. And actually I have to back up for a minute. Okay, I'm going to erase this here. Let's take this out. I made a mistake, so just erase a little work. I forgot to factor out this guy here. I forgot to factor the 5 out of that, so it's going to be 6/5 because I want to get 6 after I factor out the negative 5. I changed my sign, but I forgot this. Okay, so again, let's try it again. Let's take half of it. So when I take half of it, I get negative 6 over 5 times 1/2, which is going to give me negative 6 over 10, which is going to reduce to negative 3/5. Okay, and now I take that and I square it. And once I square that, I get 9 over 25. Okay, so that 9 over 25 then is going here, and it's going here. Okay, so we have it right this time. All right, now that it's like this, then I have the ability to go ahead and write it in the form I need it in, which is -5 parenthesis. It's going to be x minus this guy here. That's going here. And then close parentheses, square that is equal to, now the negative 1/5 plus the 9 25ths is going to give me 4 over 25. Okay, so then I have brackets on that. At this point, I can go ahead and distribute this 5 back here and to this guy, and when I do that, I get -5 x minus 3 over 5 parentheses squared is equal to -4 over 5. And now I want to get everything on one side and say it's equal to f of x. So I would say f of x is equal to -5 x minus 3 over 5 squared plus, because I moved the 4/5 to the other side, this, and that is going to be my transformation form. Okay, and if you look back to the original, that's the form that I was looking for. And that's probably the hardest one to do, where you're completing the square. All right, now we have one in x-intercept form, and we want to convert it to transformation form. All right, so again, let's recall what transformation form is. Transformation form is, just like we did in the last one, a x minus h quantity squared plus k. There are, different ways to do these, but keep in mind on this one, what you need to know is that hk is the vertex, so we need to find the vertex. And if you recall from this vertex form, it's pretty easy to find that vertex. So to find your vertex from this form up here, all you do is say, okay, the x coordinate is going to be, if I take 3 plus -2, which is coming from here and here, the average of those, which is going to be my x-intercepts, and I simplify that, I get 1/2. Okay, so that's the x-coordinate of my vertex. Now if I find f of 1/2, then that's going to give me my y-coordinate. Okay, simplify this, and I get -1.25. So that means that the vertex is going to be the point 1/2, -1.25. And I'm doing all this using those formulas. So now I can say, okay, well, my vertex form is going to be, or I'm sorry, my transformation point form is going to be, I have to use my a out front, x minus 1/2, parentheses squared, and then minus 1.25. Okay, and then that is my transformation form. All right. And now we're going to take this a step further, and we're actually going to find the solutions of this polynomial form quadratic by completing the square. So again, we want to complete the square. All right, so again, we have this leading coefficient, which makes things a little more difficult. I'm going to rewrite this as 2x squared plus 12x. A blank. I'm going to move my 23 to the other side, and I'm going to leave myself a blank. And now I have to deal with this, so I factor it out. X squared. This time I'm going to remember to take the 2 out of that 12x. It's a little easier this time. And then out of my 23, so I end up with -23 over 2 and a blank and my brackets. All right. So from here, I take my linear term and I take half of it, which is going to give me 3, and then I square it and I get 9. That 9 goes here and that 9 goes here. So I had +9 and I have a +9. Okay, so now this can be rewritten as 2, and then it's going to be x plus 3 quantity squared, and that 3 comes from here, is equal to, and then the negative 23 over 2 plus 3 is going to give me negative 17 over 2. Okay? So from here, keep in mind what it's saying is find the solutions by completing the square. Okay, so if I'm just finding the solutions, then just like I did in the last, in section 2.2, what I do is I just take this, and I'm just dealing with that. I've got x plus 3, quantity squared, is equal to negative 17 over 2. So if I'm finding the solutions, I take the square root of both sides. Let me do that in a different color so that you know. I'm taking the square root of both sides because I want to find out what x is. And when I do, I have positive and negative here. And then I end up with x plus 3 is equal to positive or negative square root of negative 17 over 2. And x is equal to negative 3 plus or minus square root of negative 17 over 2. So at this point, hopefully you will recognize, like we did in one of the previous examples, that you have a negative here in this square root. So that's not going to be a real solution. So in this case, there are no x-intercepts. There is going to be no real solution. No real solution, and again, it's because of this negative here. All right, we have one more example, and we're going to write this polynomial here that's in polynomial form in transformation form. Okay, so transformation form means completing the square. Last time I did this, I did it by completing the square. This time I'm going to use it by finding the vertex. So if we're writing it in transformation form is going to be this. Okay, and what we need to do is find the vertex. So I can do this by completing the square, or I can go and find the vertex first. We already know what our a is going to be. So if I were to factor out that a, the a value of 2, and I use my vertex of 2, I'm sorry, if I use my vertex, then I should be able to write this in transformation form. So here we go. My x value of my vertex is going to be negative b over 2a, which in this case is negative 12 over 2 times 2, which is going to give me negative 3. Okay, so that's the x-coordinate of my vertex. And now if I want to find the y-coordinate of the vertex, I find f of negative 3. So I've got 2 times negative 3 squared plus 12 times negative 3 plus 23. When I simplify this, I am going to get 5. Okay, so my vertex is the point negative 3, 5. Okay, now keep in mind when we are writing this in transformation form, we want our a factored out. So our a in this case would be 2. My vertex is going to be x minus this x here, so it's going to be x plus 3, quantity squared plus my 5. Okay, so there we go. That's what it is, and that's what you'd get if you completed the square also. Now we could check this just by multiplying back out and see if we did get the polynomial form. So I'm just going to check. Not something that you always have to do, but certainly if you need reassurance or if you want to do the problem a different way, f of x is equal to 2. And if I square the x plus 3, I'm going to get x squared plus 6x plus 9 plus my 5. And then I distribute that 2x squared plus 12x plus 18 plus 5. And then 2x squared plus 12x plus 23. And you notice that this is what you had in the original problem, so it does check out. And this is going to be your transformation form.